Oh yeah, let me get over here. And this is a really easy question. The outputs, logic, what and what? Yeah, they're logic highs and lows, aren't they? Lows or ones and zeros. I can call it true, false, yes, no, whatever. Okay, now, any questions or comments on flip-flops? So we did this. Now we're moving yonder. Let's go, tri-state next. Let's get her done. Basic definition of a tri-state device is to what? Yeah, organize data on the short bus or the long bus, doesn't matter. Because you all ride the long bus, right?
They give us short buses over there.
So this device is basically just a buffer. It's a buffer. If I put an inverter on it, I can call it what? Inverter, not gate, yeah. So a couple examples here. We have to determine the output. But it's more than just sending a bit of data through. What has to happen in order for this thing to work? I have to have it enabled. So 3 states I can have for a tri-state device, because duh, that's including in, try. Try's not by, try means 3. What do we got?
High, low, high, Z.
Can you triple stamp and double stamp with that? High, low, high, Z. What does that reflect or infer to? 3 states of what? Outputs. 3 output states. So in order for this to output anything, such as a high or a low, I have to have everything enabled. This is my enable input. Whenever, as said a few times already, we're dealing with a signal name or a function, refer to, hey, if there's no inverter, it requires a what? Logic high. There's an inverter, requires a logic low. Whenever we're dealing with inputs and outputs, if there's no inverter, the output's the same. Okay? Inverter, oh, the output's going to be the opposite or 180 degrees out. A couple examples here. Let's see what we remember. Output is? Is it enabled? That's the first thing you look at. Is it enabled? Yes, it is. It requires logic high. I have a logic high in my input. There is no inverter. Output's a 1. What about this thing? Is it enabled?
Yes.
I have a logic low because now I put an inverter there. Now I have a logic low on my input. There is an inverter on my input. And it doesn't matter if it's here or here. It's like a NOT gate. As you just cover this thing up, oh, it's a NOT gate. That's on. You know what I'm saying? Output is logic high or 1. What if I came along and did this thing? Is it enabled?
No.
Why?
The high on
Kid, why is it not enabled?
Because enable means a low side.
Yes. So I'm starting to me. So since this is now not enabled, this logic low is sitting here just cream the crap out of this. You know what it look like? It looks like a piece of asparagus got stepped on and smashed on my board and fellas got to clean it. What's the output state though? High Z. If this thing's off, it's high Z. High impedance, because Z is impedance, isn't it?
Yes.
Can we say high impedance to the load? High Z, high impedance to the load. It's the same thing. Here, I can write it down. In impedance, I'll write the word. High impedance to the load, high Z, same thing. A couple other things we have to look at with this, though. This is an exploded view of what's going on inside. We still have our input, output, enable. So we can look at it as transistor-transistor logic is what it's called, or TTL. They are placed in what? What's the other thing? Yeah, they're in series, which we can call it totem pole. What's required to enable this thing? Look at it. He's a high. Okay, so we'll turn this thing on. What's going to cause the top transistor to conduct or be in a high state? Okay, so let's see. Remember I had the what? I had an AND gate drawn inside and an inverter, rock hill, hill, and hill. So 1 and a 1 on an AND gate output is what? High or logic 1. So that goes here. This one will conduct and act as a current what? Source. Current source. So, hey, it's considered high. You can also refer to this as the what transistor? The top transistor. Now, if I come along and say, hey, I don't want that as a current source. Probably need a logic low to make this thing act as a current sink. I still need a logic high to enable this thing because that's what it requires. So now I have a high and a low. Input on my AND gate, output is a low. Low spelled here. Now this one's off. The more negative potential on P material, cause that would be off. While this one, this low, gets inverted to a high. Q2 on. Bottom transistor acting as a current sink. This is a way or means to have data utilize the same conductor either in or out. It's a method that can be used. Questions? I know you dropped stuff. Questions on tri-state device? How difficult is that one? It is not at all.